Okay, that's the magic sound to say that the internet is recording for posterity our meeting. And for those of you who haven't joined us before, it's better to have your microphone on mute and then unmute when it's time to speak. So one of the things that I said at a previous meeting is that what first impressed me so much about Auroville is that they were people who were putting their ideals into action. And to see the struggles and the lack of food and the adjustments that a lot of these Western idealists had to make to live in India, they suffered in the early years because there was a lot of heat and not much shade and not much food to support them. So it was a pioneering, truly pioneering existence in Auroville. And what moves me very much now is that Auroville is a center for sustainable living, modeling many good works in ferrocement, in permaculture, in water conservation, in voluntary simplicity. There are still people who are living, in spite of the affluence, very simple, hardworking lives. And one of the institutions that seemed so extraordinary to me was the Earth Institute. And it was Satprem who began this work, and then Lara who joined him. And for years, we're training people from all around the world. And I thought, this is so important that Auroville be relevant for the needs in the world and housing, low-cost housing, to be able to build something there where you live and have it be safe and protect you from the elements was an extraordinary work. And I had heard an anecdote early on that Satprem was in Turkey and building something from earth brick that was considering the earthquakes, and that the local people were watching with great intensity because low-cost housing, and we're facing it right here with the exodus from New York during the COVID times. There is not enough low-cost housing even here in Ulster County and Woodstock. So I think this is an essential work that Lara has been doing, and the fact that she's also an artist, that she also collaborated with a local musician, Pauline Oliveros, and had this background and training from MIT, really is an asset. And we're so delighted to have her at Madhugiri and visiting us, and that she agreed to share some of her experience with you as part of our virtual AUM. So Lara, please unmute and share some of your work with us.
Thanks very much, Julian. It's really been a great honor for me to spend this this time at Madhugiri, and also to be the fly on the wall for this virtual AUM, which is bringing together so many people. So I'm just going to go over and switch this to the presentation. Give me 1 second. Entire screen. Okay, can everybody see the first page of the presentation?
Looking good.
Okay, great. Just checking. So, so again, my name is Lara Davis, and I'm giving a presentation called "Can Earthen Buildings Improve Local Ecologies?" And that's also a little bit begging the question. We talk a lot about sustainable construction and sustainable buildings as mitigating somehow the impact of climate change, but I think that a really big paradigm change is upon us right now to demand actually that buildings start to ask the question, how can the ecology be improved with each development? Or I just wanted to say the presentation this afternoon talked a little bit about the sacred and profane, where not only will I speak a little bit more on the very material realm, but I'm going to zoom in a lot to give you an understanding of what means earth as a building material. So the better part of the last 9 years, I've been serving as the co-director of the Auroville Earth Institute, as Julian said, and spending a lot of time educating young architects and engineers and other types of building practitioners in how to build sustainably with earth. And when I say that I'm going to be zooming in, we'll go even a little bit further to talk about how special earth is as a building material, how diverse it is all over the world. And we're talking not just in terms of characteristics of the earth, the color and the texture, the grain size, etc., but even at a microscopic level, clay, which is the living particle of the soil, the particle that basically allows an earth to have a binder, to come together like a concrete. So earth is like a concrete with, instead of cement as a binder, the clay itself serves as a binder. So this is just about as zoomed in as I'm going to get for this presentation. And then we're going to start zooming out to look at how can we look at the material on this level impacting a whole other scale of sustainable development in the world. And how can we understand and come to understand the role of Auroville and the relevance actually of Auroville in mitigating and mitigating climate change and impacting local ecologies. So just a little bit more on the material. If we take 1 cubic meter of rammed earth wall, we have more than 600,000 trillion grains. And yet we only need a quarter of a liter of water to serve as a binder in order to make a loose earth into a building material. And that's without even needing any cement. But we can use raw earth in and of itself alone, like we see that the adobes on the left, or we can stabilize earth and compress it like we often do at the Earth Institute in Auroville with a very small percentage, only 5% cement, in order to serve as a building material even in very, very difficult climates, in tropical monsoon climates like Auroville. Oops, sorry. So we're at the Earth Institute, we're using compressed stabilized earth block for the most part, but I'll show you various different types of earth construction techniques. So here we have different vernacular construction techniques, adobe or wattle and daub or laterite block, which is common in certain parts of India, cob or earthen plasters, rammed earth, or compressed stabilized earth blocks. So just to give you an idea of the overall language, there are 12 different vernacular earth construction techniques and 14 total earthen construction techniques that we can actually use today. And we spend a lot of time drawing from the vernacular or local traditions in order to look to ask the question of what are the best low-cost construction techniques for a given location in the future. And again, there are many different types of earth construction techniques. These are just a few: rammed earth, compressed earth block, poured earth, adobe, wattle and daub, or cob. And all of these various different techniques have different textures and characteristics, and can be applied in many different ways. But generally speaking, to give an overview or what are the benefits of earthen construction, soil as a building material, basically, well, almost all soils can be adapted for construction, although one of the important things is we never use arable soil or humusy soils, which are so important for agriculture and for growing the green surface of the earth that we need. We only use mechanical subsoils. But we have such a wide range of soils all over the earth. in a very extreme diversity of different climates that can be used for construction. Earths are always very locally available and abundant, and in fact can be said as the most abundant, lowest cost or affordable building material in the world. We don't require any energy, and we can use sometimes even zero energy, just physical labor for production of earth construction techniques with a very, very low carbon footprint. 100% recyclable, meaning when we're finished with buildings, they can be broken down, go back to the land, or be reutilized for future buildings. We can dramatically reduce the impact of imported building materials like cement, which is now being transported in really the measure of thousands of kilometers from point of production to use in the world. And it's a labor-intensive construction method, which means that we're working with local people, investing in job creation, with maybe 65% of the investment being towards labor itself and towards local economies, value chains, and livelihoods, sustainable livelihoods. And this is an overview map to show that almost more than 50% of the world population still lives in earthen buildings. So this is not just a technique of the past, but dominant in the world's kind of language of building, of home building, etc. Again, I want to kind of somehow uniquely with this lecture ask the question, what is Auroville's relevance to earthen construction technology, and how does that reflect on traditional building technologies all over the world? So there's a concept called earthen cultural landscape, and this is just an image in Algeria, one of many that I visited in my role at the Earth Institute. Where we see an overall landscape with vernacular earth construction techniques in mostly adobe, where you can see this total kind of co-creation of a built landscape and of a natural landscape. And this concept of earthen cultural landscape is just kind of somehow like focusing on this question of co-creation of natural ecology and of built human landscapes, but with the sensitivity of vernacular construction, a sensitivity of people with a lot of know-how about what soils people have locally. And there's not just one soil, but so many different soils are available in a local place, and the knowledge of the people as knowledge holders, allow us in a way to very intelligently use the most available local resource, earth, not just for buildings, but for agriculture, for flood agriculture or dry agriculture, for building materials, for filling, for terracing, for plasters and other techniques. And now I think, uniquely with this lecture, what I'd like to do is kind of draw a little bit of a parallel with Auroville, because this is the foundation of Auroville on 28th February 1968, where we have earth actually used in a symbolic way, where we have people from 104 different countries dropping a handful of earth in the urn next to the matrimondier as a testament to human unity. But actually, we like this because it's symbolic, but it's also realistic. Where at the beginning period of Auroville, and this is the excavation of the matrimondier, everything in Auroville had an aspect of excavation of soil and movements of large quantities of soil, in a sense of sculpting the landscape. So both in the example of earthen cultural landscape and in the examples of early Auroville, where the matrimondier was being excavated, we have this question: how can we sculpt the land? And how can we sculpt the land with a maximum understanding of the sensitivity of that local ecology? I just thought to add this short bit from God's Labor, a poem by Sri Aurobindo. He who would bring the heavens here must descend himself into clay and the burden of earthly nature bear and tread the dolorous way. So the karma yoga of the pioneering years of Auroville, and certainly of the Earth Institute, is this incredible work of land sculpting, earth sculpting. And in a great deal, that was one of the pioneers' first tasks, was to start building bunds all over the landscape, to shape the landscape to retain water. And you can see from these, the land shaping was so important because, as everyone knows, and many of you have known of Auroville for a really long time, but just to show these images, that the landscape was so barren and denuded. It was so affected by the deforestation of the colonial empires, really, in India, that that there was no longer any of its initial forest existing on the land. And the pioneers had an enormous task at hand to sculpt the landscape, to build up bunds, to build up dams, in order to retain water on the landscape so that something could grow, and so that, a community could begin. So this, so first shaping of the soil to retain water, to be able to regrow again forests, and Auroville is one of the really stunning examples of growth of new forest in a contemporary time period. But to keep all of this really important arable soil, or humusy soils, from being lost in large rivers of red runoff to the sea. And keeping in mind that India at large is one of the red hot zones in the world of water risk. And even when we zoom into India alone, Tamil Nadu is in the very reddest area of extremely high water stress. And that's been one of the real wins of the pioneering years. So while there are a system of local tanks that were built up thousands of years ago to retain the water, so critical in this climate, a lot of these tanks have no longer been in use. And the work of the pioneers was really to begin to shape, again, sculpt the landscape, sculpt the soil to be able to retain water, to repercolate it and recharge really stressed local water aquifers and the water table. So we still see, in a present context, areas like this where we have quarrying of soil for roads, and loss of arable soil to the sea, a lot of erosion and what's called desertification. It's loss of arable soil. But we have this opportunity in basically every moment of development to ask, what can this excavated soil be used for? And by excavating local soil, then how can we shift and shape the local ecology? This is just an example of how soil can be excavated for building, or for, in this case, decentralized wastewater treatment systems, sustainable infrastructure, basically. Or just, you can't see it here, but all of this has been shaped for sand pits for rapid water repercolation to the aquifers. And as I mentioned, in Auroville, we have this incredible case study of basically 52 years worth of reforestation using the local tropical dry evergreen forest typology, and basically recreating a local biodiversity which had been at risk for for many decades since the beginning years of colonization. So in Auroville today, we have this lush landscape with this beautiful South Indian tropical evergreen forest, and this really did not exist at the beginning of Auroville. So I want to show you just quickly a few different pioneering projects of using earth as a building material, and many of you know Popo Pengal, who worked in village construction with rammed earth with affordable housing in the early years. And this is quite similar to some of the traditional village construction, which I must say is one of the best bioclimatic building typologies of the climate still to this day. And I hope that before some of these techniques are completely lost, then people start to realize how just ideal they are for human comfort in such a hot and humid climate as Auroville. But in this case, Popo was using rammed earth instead of cob. We have other pioneers like Ray Meeker, who was basically building with raw earth block and firing his entire house like a kiln. Very unique vaulted earth buildings that some people travel from all over the world in order to see these rare examples of fired houses. Or many, many examples of basically home build. In this case, this is a wattle and daub house at Newland community. Some of you might know Roby's place. And this is, to this day, again, one of the best building typologies for a hot and humid climate. So we have quite a lot of self-construction in Auroville with earth as a building material. And maybe some of you might know Ajit Kuljalji and Ratna, who not only build their own house with raw earth. Ajit, long before his passing, used to tell me, Lara, we don't have to put any cement in the soil. We can just build raw and use beautiful lime plasters. And, you know, this is just a view of some of their work together, but basically represents the incredible work of conservation of traditional architecture that goes on at intact Pondicherry. And another architect, Dr. Amona Dr. Pingle, who was working quite a lot in the German bioconstruction theme, working with very special types of domes. And maybe some of you will recognize some of these structures. Very special type of dome typology. And then some of the classic buildings in Auroville, like the visitor center shown here, collaboration of Suhasini Iyer and Satpram Maini, Satpram being the founder of the Auroville Earth Institute. And we just celebrated his 30-year anniversary not too long ago, of coming to Auroville and starting to really work with people to spread the technology of earth as a building material. Many of you who have been visiting Auroville for years are very familiar with this building. And Satpram also built Vikas, which is one of a pioneering building of one of Auroville's highest density housing that's built with raw earth, with basically with earth as the entire load-bearing system on 4 floors. So for anybody who has doubts about the longevity or the strength of earth as a building material, all they have to do is come to Auroville and take a look at 4 stories of compression-only use of earth in a monsoon climate, and then start to gain confidence in the capacity of earth to be available for affordable housing in India. This is also Vikas. And also some contemporary architecture as well. So David Nightingale and Ganesh Bala have built with rammed earth at Verite. Very beautiful use of light sculpted on the rammed earth. And Do Studio is another office that builds a great deal with earth, that that builds and kind of caters to a sort of elite high architecture, as well as to local village builders and vernacular construction techniques. And Suhasini, again, with her firm Auroville Design Consultants, recently built a beautiful project called Humanscapes, high density housing, where you can see some of the sustainable water infrastructure in the front, where she actually worked very hard in order to get earth building materials and vaulted masonry systems onto the Government of India register of building materials, so that this technology, using also poured earth concrete, some research from the Earth Institute, to allow that to be disseminated as widely as possible in India in housing projects. So that's like a really, really big deal, is that now for the largest housing projects in all of the world, that now slowly they can begin to use the most cost-effective and low-carbon building materials like poured earth. Library by Suhasini. And the last project I'm going to show you, a project, just to go in a little bit more depth, in a project that was built by Satpram and myself together with our team and all of the Masons at the Earth Institute, project called Sharanam. And the phase 2 buildings we built in 2 years, about 2,000 square meters of basically dormitories, single-story dormitories, and double-story dormitories for a village development center right on the outskirts of Pondicherry. This is for the Sri Aurobindo Society. Just a few views of some of the double-story structures right before they were finished. And for this project, for Sharanam Rural Development Center, again, for the society right on the outskirts of Pondicherry, some of you know Ustiri Lake, and the area of Ustiri Lake was very badly quarried for the use of regional road construction. And the quarries are in such terrible shape, actually, some like the photos I showed earlier in the presentation, that it's quite a danger to the entire ecosystem. It being Ustiri Lake being this major area of the water aquifer for the water stability of the entire state of Pondicherry. So we were given the site, worked with the society and a couple of masons for the architects rather, for the phase 1 construction, to build a low carbon campus, which attempted as much as possible to contribute to regional land management and climate resilience. So about 76% of local soil resources were extracted from the site, meaning like the percentage of imported material, cement, steel, more industrial building materials, was really quite small in comparison, which means that just like Auroville, we had the opportunity to excavate a great deal of soil from the site in order to sculpt or shape the landscape, like we were discussing before, the concept of the earthen cultural landscape. When we can move soil, then we can shape a landscape. And when we can shape a landscape, we can ask the question, how can we positively impact the local ecology? And I'll zoom in a little bit further. Now we're at the architectural scale to show a conference hall that we built. But first, to give you an idea of just how much soil was moved on the site. Here, the JCB is loading up a tractor in one of these very, very large soil percolation pits that were incorporated into the landscape. Basically, by excavating all of the soil, we could use it maximally for construction on the campus and shape the landscape to be able to retain all of this water at the top of the watershed for crucial resilience of the water table in the state of Pondicherry. Another view. So it's quite a large mass of soil that was excavated on this site from what had been a very poorly quarried area to bring it back, as Auroville had been brought back from a denuded landscape into a lush green landscape where all of the rainwater in the monsoon season is restored to the aquifer. And the conference hall is basically using poured earth technology developed in the last 10 years at the Earth Institute, which is very rapid to cast, but it uses large percentage of soil and some stabilizer for load-bearing walls. And the special thing about this building was that we had a conical vault of 15-meter span. That's in feet, it's 49 feet span with a minimum thickness of about 7 inches. So that's a fully, that's a fully load-bearing masonry building with the use of CSEB or compressed stabilized earth block for the vault. And again, the special technology called poured earth, which is the superstructure. So it's a very, it's basically like a low strength concrete, but it's very, very, very high strength enough that we could carry about 85 tons worth of roof system on top. So it's low strength for concrete, but totally sufficient for multi-story construction. And it's like basically classic concrete, except we use very small amount of cement and lime and the most amount of earth possible. So I think the carbon impact of this is about a quarter of the emissions impact that it would have been if it was a concrete wall. And this was the special part of the construction. We built this conical vault, which had a maximum of 49-foot span in the free-spanning technique, which is something coined by the Earth Institute and in fact developed by the Earth Institute out of a similarity to the Nubian vault construction technique from Egypt, initially from Egypt. So in this technique, basically we have earth block, which is laid vertically with a stabilized earth mortar. So we don't need any formwork under the structure. You can see that this vault is being built. The masons are sitting below after a long day of work, where there's no formwork at all, only scaffolding for the masons to stand on and build. And only a series of mason's lines or string lines that are pulled from one side to the other to tell the mason where to lay the block. And you know, this is actually significant in the sense that this is one of the largest span earthen, single curve earthen vaults in the world. To my knowledge, it is the largest single span earthen vault in the world. And, you know, at the beginning, you know, when we laid up the first arch of the course, it was 49 foot in span and only 2 inches in thickness. So it was really quite an endeavor. So here you see the earth block is basically being glued to the surface, and it can only be glued to the surface like this with no supporting formwork because of the special properties of soil we talked about before, the use of the clay with basically that gives a capillary suction, and once it's set, then you use actually the electrostatic bonding capacity of the earth to just glue the blocks onto the surface. And actually, it's pretty rapid. This whole vault, I forgot the square meters of the surface, but quite a large vault was built over a period of about 5 weeks. So, I've zoomed around to different scales here when talking about, the kind of karma yoga of construction with earth. We're back at the building scale again, but we like to, at the Earth Institute, look at different scales. The scale of the material itself, the scale of the building, the scale of the overall site, the scale of the entire ecosystem of that particular area. And by looking at different scales, we can ask ourselves, well, when we work at the material scale, it's very small like this, can we make decisions that impact a whole local ecology, that improve a whole local ecology to address not only, for instance, in this case, a very denuded site from excess quarrying, but how can we improve it for the long duration of the needs of that particular region? This is just when the raw construction was finished before we completed the building, and this is basically how the building stands today. A conference hall that's used for the Society for Education, for village education, for different types of cultural programs like dance and Sanskrit courses, etc. So I'm just about to end here, but for me, I think this was the project where I could get the closest to asking the really big picture questions that I've been asking for a long time. Again, the title of the lecture, can earthen buildings, or can buildings at large, be used to improve our local ecologies and not just mitigate the impact of building? And I think the answer is yes, they can be. And not only can they be used to improve local ecologies, but now the discipline of architecture all over the world needs to critically start asking the question, each time we design a building, each time we design a campus, how can, not can, but how can buildings be used to give back and to improve local ecologies? Thank you very much. So maybe we can move to the questions and answers.
Yes, I encourage people, you can type a question in the chat, or you can raise your hand. You see the little at the bottom of your screen, this icon. You can click on that to raise your hand, and then unmute yourself and ask Lara a question about this absolutely wonderful work that they've been doing in Auroville. Yes, I agree. Wonderful.
Thanks, Karen Das. I know this presentation is very different from many of the presentations in the AUM, but I think that it's, I'm grateful to Julian to give me the opportunity to talk a little bit about the very material nature of some of the karma yoga that's being done in Auroville, and also to, give a tip of the hat to some of the pioneers who have really come before us and really laid the groundwork.
So I don't know whether if you click on the chat box, Bill Leon had a question. Is poured earth the same as rammed earth?
Oh yeah, no. Poured earth and rammed earth are very different techniques. Rammed earth is a construction technique that is, it can be, I think in certain areas like in the Himalayas about 600 years old, or there are long, long traditions of building with rammed earth. Poured earth is a very new building technique, and basically it capitalizes on a global culture that's crazy in love with concrete construction. And we at the Earth Institute, we're not lovers of concrete because this is maybe up to 9% of global carbon emissions come from concrete. But the technique has been developed, and again, like, well, now maybe 9-10 years worth of research at the Earth Institute in order that this type of technique is now being broadly disseminated locally. Is different in that it uses the same type of formwork systems as concrete, the same types of construction methods. So basically, you mix your earth concrete in a rotating mixer, and it gets vibrated by a vibrator inside of the formwork. So when you know when kind of looking at the big development question, what type of technique would be most readily accepted in a local community, you always want to ask the question, what's most prevalent. And now that earth or that cement concrete is so prevalent in the world, is being used so much, and disastrously so for the ecology or for the environment in general. Uh, Adapting the technique to use up to 50-60% is just raw earth from the site, and it gives us a totally different access to a much broader market, and to impact the building market in a way that can really dramatically reduce the carbon emissions without asking people to change the way that they want to build. So that's a good question. And Pravir asks, can you please share a little more on how specifically the last conference center you showed us benefits the local ecology? Yeah, so the site that I was building on was literally right across the street from Osteri Lake. And for those of you that that travel to India and to Pondicherry, just go for a drive along the area of Osteri Lake, and you see this disastrous area of some of the worst quarrying I've ever seen in the world, by just trucks for several decades, just totally took away all of the soil. So all of it is just the worst nightmare, like what Auroville was, of canyons of eroded arable soil, everything washed away. All of the good soils and clays washed away to the sea. And most importantly, these quarried areas would not capture all of the monsoon water to restore and recharge the aquifer in this very crucial place at the top of the aquifer near Osteri Lake. So basically, if Osteri Lake dries up, then the water stability of Pondicherry is zero. It's its only major aquifer area. So basically, that means that any of the landscape around Osteri Lake is so important to make it have zero runoff, to recharge as much into the local aquifer as possible. And so not only is that possible now that the whole site was resculpted in controlled terraces to make sure that there was no runoff and a no loss of topsoil. So now it's not being planted in the way that Auroville was with TDF, with tropical dry evergreen forest trees, but it's now a beautiful, stunning landscape today with green growing everywhere. And once you have that green layer that's growing on on the landscape, then the ability of the land to recharge the water table is much, much improved. Did that answer your question? Yeah. Okay. Is poured earth difficult to learn? From John. At first, I thought it would be. At first, I thought poured earth was going to be very difficult. It turns out the most difficult part of poured earth concrete is the mix ratio. And in this case, depending on the soil type, sometimes it can require an expert to come in and say, this is how you want to modify your local soils. But once a good mixed ratio is given, it's actually very easy for local builders. So when Suhasini built Humanscapes, we basically sent a team over to train their contractors that only work with concrete, really. And after about, I don't know, 5 training sessions, maybe it was less than that, maybe it's only 3 training sessions, they were able to just build the entire complex. And then it was listed for Government of India grant projects, construction projects. And then we found out by accident, oh, it looks like they've used the same technology now for a whole bunch of other buildings that are being built in the Auroville area. In fact, now when I ride my bicycle past the visitor center down to Irambai area, there are buildings that are now using earth concrete that just happen to be the technique passed, word of mouth. And when you start to see that happening, that's really, really encouraging moment that you don't need to actually actively disseminate the technology, but it means that it's easy enough for people to learn and to teach to other people. So who knows what will happen in the next 10, 15 years if we'll have a whole space of different earth concrete buildings. It's possible.
Thank you. Great presentation.
Thank you. One from my mom. Can you build with soil in cold weather as well as warm? Is soil-based building safer in colder climates? Or is it safe in cold climates? Yeah, I mean, I was working in an area in the Himalayas where it's minus 35 degrees centigrade. Can anybody give a rapid Fahrenheit conversion? Minus 35 degrees centigrade is like as colder as you can imagine how cold is. It's the altitude is more than 12,000 feet. So it's very cold up in that climate, and they used rammed earth. Maggie. Sorry.
31.
31.
Fahrenheit.
Right. Minus 31 Fahrenheit.
Yes, minus 31 Fahrenheit.
Yeah, yeah. So we in the northeast of the US, we don't have a lot of earth construction, but we can have it. In fact, because earth doesn't freeze. It's the special nature. There's still freeze thaw effects that you have to design for. But normally that helps by bringing a higher plinth to the building and detailing it. No, all the earthen buildings have to be designed specifically for their own climates, but they've been built in the only climates that earth buildings have probably never been built in is when you go so close to the poles that there's no more soil. So yes, it's safe in cold climates too. Although most in the US, most of our earth building culture is around New Mexico with adobe construction. Karandas asks, is it feasible in the West? Absolutely. Yes, totally. Oh, thanks for the conversion, Julian. Did I miss anything? Are there other questions, or does anybody want to use their voice?
Martha asked if you can have a flat ceiling, which might also imply a flat roof.
Oh.
And also Mira had her hand raised if she wants to ask something.
Right. Okay. Flat ceilings is something that's very, very difficult for earth to do, because when you have a slab, then you have basically bending moment. You have a slab is a combination of tension and compression, and in order for that to work in concrete, then we have reinforcement. We have steel that takes the tension, and the aggregate of the concrete is taking the compression. So that's a little bit difficult to do with earth building systems because the earth and the steel don't bind well together. So it's difficult for that tension and compression to work together. But there are different techniques that we've used. I mean, if you have, for instance, a timber floor, then you can ram a small amount of earth on the top of it, and it can be very comfortable in cold climates, even with bare feet, if you have the right heating system or insulation system. So in Spiti Valley, the area where I mentioned I was working before in the high Himalayas, they use a lot of flat roof systems with timber, and then smaller members of wood, and then some sticks and branches, and then earth that's rammed onto the top. But we don't have a lot of earth building techniques being used for floor systems in a modern context, with the exception of when we start building with shallow vaults. And that's something that I've done rather a lot in my career in the last 15 years. Maggie, is that a hand? Yeah.
Would it be, so let's say that we wanted to begin to push it in the US, would it be considered more expensive because it's new?
It would be considered as more expensive because for the last 80 years, the US building market has been going away from labor-intensive construction. So the cost of labor is so high that, and in fact, there were a great deal of vaulted roof systems that were built in the beginning of the 20th century by a system called Guastavino vaulting, which I studied for a long time and built with. And you have Boston Public Library, a lot of the great, Columbia Library, a lot of the great public buildings of that time were built with brick vaulting. And after about 100 years, or maybe it was 80 years, that particular business really started to suffer because the inflation of craftsmen, of building costs, of labor costs. So it can be difficult, like in Santa Fe right now. It's in vogue to build with Adobe, and some of the real millionaires in the Santa Fe area are paying top dollar for Adobe houses. So the building material itself is so cheap, but the cost of labor is very, very high. So fortunately, it's in vogue for the upper echelons, but it's not really accessible in the US for a lot of people in the kind of like middling areas, certainly not for affordable construction. But places in the world where we still have low cost of labor, like in India, it's much more, or when people are building their own houses, like a great deal of the Indian housing projects is still self-construction. It's still really quite valid. So Karandas says, by feasible, I meant what would it take to train and work with contractors, architects, etc., to make it acceptable? Yes, just training. You have to be organized, of course, to teach a contractor what are the right proportions to use and what's the sequence of construction, what material do you put into a mixer first and second and so forth. And that's very kind of simple how-to. But but earth concrete is much faster in construction than Adobe or other brick construction because you don't have to produce the brick material well in advance. You can just excavate the soil, make sure that it's dry, crush it, and then start to mix it in for a concrete. So you can have a large wall concreted in one day. And Mira Nakashima, it's so nice to see you here, asks, is there any reinforcement necessary? How do you calculate strength of earth to concrete? Yeah, we would get into the kind of nerdy stuff. We actually don't ever put steel in load-bearing walls. And I think Sharanam, the vault, is one very good example that shows how overused steel is in the market. And the calculations for the earthen wall and for the foundation system, which is also of earth concrete, is basically using very simple stress calculations. So what's the crushing strength of the material, and how do we so how do we calculate the stress so that we have really no risk at all of the material crushing under its dead load of the roof. So I think, again, the roof was about maybe 65 tons for the vault alone, but then with the waterproofing and so forth, it came to about a roof weight of about 85 tons. It's a very, very heavy roof. But if you can prove that the walls won't fail in crushing, then you don't ever need to put any steel in it, only for roof spanning techniques. But again, when you use a vault in compression, in pure compression only, then that assumes that we have no tension. In fact, if we leave the steel out of it, then we can get a building lifespan of several hundred years as long as the waterproofing is maintained. But concrete, like we've really quite tragically seen in the Miami-Dade building collapse that's on the news for everybody right now, is once we have corrosion in a reinforced concrete building and the steel starts to fail, then we fail in tension, and really kind of cataclysmic collapses can happen. And Bill, oh, you guys are asking all of the very difficult, nerdy, geeky, technical questions. I love it. It's great. Any considerations for earthquake? John asked and Bill asked what adjustments of building techniques are needed for earthquake-prone areas. So that vault had a very special series of load calculations to ensure that if we had, for instance, a cyclone with winds at 200 kilometers per hour, that it could sustain the loads so that there would be absolutely no risk of collapsing. In Tamil Nadu, we're I think that it's actually a zone 2 out of the category of 5 zones. It's seismic zones in India, but it recently was upgraded a few years back to a zone 3. But with the masonry roofs, there are certain types of tests that calculations you can do, like tilt testing. But yeah, it's one of the things that was difficult for me teaching in India, because people would come from all over the world to take the classes, or from all over India to take classes. And a lot of it was people that wanted to build themselves. So they would partner with a local builder. And it was, for me, when I was teaching about arches, vaults, and domes, I had to work really hard to educate people about this risk of seismic areas, because you can't just teach people how to build with vaults and domes and then say, oh, now you can go into high risk areas. There are lots of I mean, the craft of construction is one of the most important aspects of vaulted buildings being safe in seismic zones. And basically, we don't have that kind of craft in the world anymore. So, yeah, I'm a very like mean, harsh teacher when it comes to teaching people about seismic things, because really only the highest engineered buildings really should be built in vaults and domes in seismic areas.
Lara, I put the link to the Earth Institute, some of the videos, and I know that there's another video that shows the placing of the bricks. Is that also on the Earth Institute site?
Yeah, I think that if I can.
Well,
I
I'm
can
going to send
probably-
something out at the very end because Santosh wanted us to include his blog and little audio clips, and I would also include that film so that people can see, because it's so spectacular to see the meticulous placement of these thin bricks adhering as the vault goes up. And there's the link. So for
So
those of you who want
there's a
to,
link that's about the building, and then here's a link that. Oops, I made a mistake. Here's a link that shows a video of the vault construction, which is pretty dramatic. So anybody that wants to.
I encourage everyone to click that link now. It will open up in another window to see later, and then we'll also send it out to all the participants at the very end. So we're now at 7 minutes past the hour, and I very much appreciate your presentation, Lara. I think it's a shining star in Auroville's legacy, that they're walking the walk by having this extraordinarily relevant, appropriate technology go forward. And I'm just so grateful to you and Sat Prem and Suhasini and all of the Earth builders. We didn't mention that the Auroville Visitors Center won the Hassan Fathi Award.
Mm.
He's the author of Architecture for the Poor, and it's another feather in Auroville's cap to have these awards come in, and I'm hoping that there are more to follow. So thank you all for joining us.
Thank you all.
And we are having a session at 9 o'clock. If anyone wants to come and just schmooze, come back to this same link at 9 o'clock. And tomorrow morning at 8:30 a.m. we're having pranayama with JV. And then at 10, what I hope to be a mind-changing seminar on China and the translation of Sri Aurobindo's work into Chinese, and that whole effort that Devdeep and Richard Hartz are involved with. So thank you all, and thank you, Lara.
Thank you.
Thank you.
Bye.